Hello and welcome you all in the course of Probability and Statistics. I am your instructor Hardik Joshi. Now in this lecture we should see the example corresponding to the chi-square distribution. So in our previous lecture we have to see the whole procedure of the chi-square distribution, how we can check the population variance, satisfy the null hypothesis, that is whether the null hypothesis is reject or not reject when the population variance is known and the population means is unknown. So these are the second example. The question tells that say normal population has mean say mu. Definitely when we have to follow or apply the chi-square distribution, so at that time mean is unknown. If mean is known, so remember in that case we cannot apply the chi-square statistics. Now in variance is given, that is sigma square we have to know, so population variance is given. A sample of size, say 9 observation has been taken. Now also the information suggests that the value of n, that is there are total 9 observation has been taken and its variance is found to be 5.4. So the 9 observation is taken and its variance is found to be 5.4. Test the null hypothesis, that is H naught, that is sigma square, that is variance is equal to 9. So the population variance is suggests that population variance is 9. But when we have to collect the 9 observations, so corresponding the sample variance is 5.4. So we have to check this variance corresponding to the population versus sample. So test the null hypothesis, that is H naught sigma square is equal to 9 against the alternative hypothesis sigma square greater than 9 at 5% level of significance. So let's start the solution. So definitely in null hypothesis our first priority is whatever definition tells we have to assume it should be right. So we have to assume the null hypothesis say population variance, that is sigma square is equal to 9. So same thing we have to write down here, that is population variance regarded as a 9. Now on the basis of this we have to define the alternative hypothesis, say H1, that is sigma square greater than 9. Now here definition itself suggests that test the null hypothesis against this alternative hypothesis H1, that is sigma square greater than 9. So definition itself tells that check this null hypothesis the against of this one-sided right alternative hypothesis. That's why we have to consider this one-sided right tail test, that is the population variance is regarded as greater than 9. So in step number 2 we have to gather the data. So to check the sample variance, the definition, that is whatever organizer they have to collect the 9 observation, that's why the size of the sample n is 9. Now it is reported that when they have to collect the 9 observation and on the basis of this 9 observation they have to observe the variance, that is known as the sample variance. So remember here we have to write down sample variance as a symbol S square. So sample variance is denoted by S square and is equivalent to 5.4. Now this information is given in the definition. Step number 3, we have to define the level of significance. So level of significance is 5%. Yeah, sometimes it may be also referred as 0.05. Step number 4, we have to identify the test statistics. So it is already defined here in the starting of example. We have to say that we have to check or we have to see the example corresponding to the chi-square distribution. That's why we have to consider the chi-square statistics, say n minus 1, that is total number of observation minus 1 into S square, that is the sample variance, upon sigma naught square, or sigma square, that is the population variance. Now the information tells that this chi-square distribution has degree of freedom is n minus 1. where n is the total number of observation and it follows the normal distribution. So in step number 5, we have to find out the observed chi-square distribution. So the observed chi-square distribution on the basis of the null hypothesis is calculated as, say, n minus 1 upon sample variance upon population variance. So n, there are total 9 observations is taken, so n minus 1, so 9 minus 1, so 8. Now sample variance is given in the definition is 5.4. Now population variance is also given in the question 9. So 8 into 5.4 upon 9. So by simplifying this, we have to gather or collect the value of observed chi-square distribution is 4.8. So these are the observed value of the chi-square statistics. Now step number 6. To compare this observed value with the critical, that is tabulated experimental chi-square value. So to find out the critical value, we have to see whether it follows the two-sided or one-sided test. So in the null hypothesis, and in also more precisely in the alternative hypothesis H1, we have to consider or write down is a one-sided alternative test. So is a one-sided alternative test, and the critical value we have to define 5% level of significance. So chi-square, that is experimental chi-square value, is chi-square E, that is degree of freedom n minus 1, level of significance is 5%. So we have to collect this tabulated chi-square value from the chi-square distribution table. Say we have to say that the experimental chi-square value is 15.507. So next slide I will show you how you can take this value from the chi-square distribution table. For that you have to remember is a one-sided test, 5% level of significance, degree of freedom. So see here 5% level of significance, degree of freedom is 8. So here now this distribution table, say all the value is write down in 2 significant digits. So that's why 15.507 can be round up to 15.51. And if we have to consider 3 digits, 3 level of significance, so it can be expanded as 15.507. But it doesn't matter, either you have to go to 2 level of significance or 3 level of significance. So the experimental chi-square value suggests that, say, 15.51. Now step number 7, we have to give our decision whether the null hypothesis is reject or not reject. So it's again, for sake of simplicity, we have to write down this step number 7, that is the rejection rule for the null hypothesis in the margin. So step number 7, now these are a one-sided tail and more precisely is a one-sided right tail test. That is, we have to say that the null hypothesis is rejected if it satisfies this condition. That is, the observed chi-square value is greater than the experimental chi-square value. That is observed, that is chi naught square greater than chi, that is chi experimental square. So see in our case what happened. So for the given sample information, that is in our case, the rejection rule does not hold, that is not satisfied, because the observed chi-square value is 4.8 and the experimental, that is tabulated chi-square value is 15.507. So definitely we have to say that the observed chi-square value is less than experimental chi-square value. So observed chi-square value is less than experimental chi-square value. So is in against of this. That is totally opposites. That's why we have to say that, say H0, that is null hypothesis, is not rejected in the favor of this alternative hypothesis. So finally we conclude that the population variance can be regarded as is 9. So thank you so much for paying your attention.